Chapter 9, Inferences for Regression. I apologize in advance if you hear some extra noise out in the hallway. There are some people working here on campus today, and I don't want to begrudge them the opportunity to do their job. So Chapter 9 is going to take what we have reviewed from Chapter 2 and put some statistics 2 flavor on it. In Chapter 2, we reviewed scatter plots, we reviewed correlation, we reviewed line of best fit, also known as a regression line, also known as the least squares line, and we also reviewed, what am I missing? Slopes and intercepts and interpreting them. In Chapter 9, we're going to do some inferences on that regression. For example, in section 9.1, we're going to look at inferences for slope. And remember, inferences just means confidence interval and or hypothesis testing. For slope, we'll be doing each. We're going to estimate the slope of the population regression. Remember, in the previous videos, we took a scatter plot that represented a sample from a population and used that scatter plot to come up with a line of best fit from that sample. We can estimate what the slope of the line would be for the population based on what the slope of the line was for the sample by using a confidence interval. We can also test if the population slope would be 0. Now, why would we want to test if the slope was 0? Well, in terms of a scatter plot, let's say that we had a line of best fit and its slope was 0. In other words, it was a horizontal line. Now, of course, these aren't all on a horizontal line, but let's pretend that when we got the equation for the line of best fit, either manually, no, or using technology, yes, we got a horizontal line whose slope was 0. Well, what does that say about the predicted y values, the predicted response values based on the explanatory values? It says no matter what x we pick, we predict the exact same y value. In other words, if the slope were 0, then this x would have absolutely nothing to do with the predicted y value because it would always be the same, which means that this variable would not be a good or effective predictor for this variable. So that's why we're going to test if the slope is 0, essentially to answer the question, is this an effective predictor of that? Also in 9.1, we're going to look at inferences for correlation. Remember that correlation attempted to measure the linear association between two quantitative variables. Correlation is always between -1 and 1, and values at the extreme end of that range indicate a strong linear association, whereas values closer to the middle, aka 0, indicated the lack of or a very weak linear association. So if we test correlation is equal to 0 and we accept that hypothesis, we're basically saying there's not a linear association. That doesn't mean there's not an association. That just means if there's an association, it's not linear. It could be something else like exponential or parabolic. In section 9.2, we're going to go back to analysis of variance, ANOVA, for regression. In the attempt to answer one question, is the explanatory variable an effective predictor for the response variable? In other words, almost the exact same question we were asking up here when we were testing if the slope was 0. It's just an alternative approach to it. The good news for both of these is that most of this will be given to you, and it's just a matter of interpretation. In 9.3, we're going to construct what are called confidence intervals and prediction intervals for the response variable for a given value of the explanatory variable. Just a quick preview of what that means. Let's say that we have a scatter plot connecting, well, bills and tips. Bill, tip. And we have some sort of scatter plot that may look like that. And some least squares line that looks like that. What we're going to do in the last section of this chapter is pick on a specific value for the explanatory variable. For example, let's say that we want to focus solely on $40, bills of $40. We can ask ourselves 2 questions. Number 1, based on what we know from the sample regression, can we estimate for the population what the average tip amount would be when the bill is $40. That would be a confidence interval. A prediction interval is something a little different. Basically, your prediction interval says, go set up an interval that'll capture a certain percent of the actual values we would see here. In other words, set up an interval that contains 95% of the expected tip values, as opposed to set up an interval that's going to capture the expected average tip value. But we'll get into more details when we get into 9.3.